Hello students, good evening all. So welcome back to our next session of chapter Permutations and Combinations. So far we are dealing with the concept permutations. We have discussed permutations under restriction and as well as rank related thing we have to discuss in our today's session. So first, before starting our today's session, we'll just have a quick overview of what and all concepts that we have covered in our previous session of permutations and combinations, and we also going to see what are the concepts that we are going to cover in our today's session of permutations and combinations. So first, as I mentioned, so far we are dealing with only the concept permutation. So as for permutations concerned, in our previous session, we have discussed the concept permutation under restriction, where we have seen some typical restrictions as well as we have learned two methods. One is gap method and the other one is string method under the permutation restriction concept. So we have understood these two methods and we have done questions related to these two methods, gap method as well as string method. So with this we have almost finished our permutations concept. So after this permutation under restriction, we are left with one more concept, that is rank. So we are going to find rank of a word, right? So there will be a random letters or random word which will be given and we have to find the rank of it according to the dictionary. So in our dictionary, we will be going by the alphabetical order. So based upon the alphabetical order, according to the dictionary, we are going to find the rank of a word. So if we go by a long procedure, so it will be taking more time, it will be consuming more time. But here I am going to just introduce to you a shortcut so that we can solve the rank question within seconds, as well as I am going to demonstrate the long method of finding the rank with example here, right? So after this rank, so with this rank of a word, we actually finished our permutation and now we are entering into our next concept, which is combinations. So first we are going to start with the combinations. So in basic terms, we are going to start with the definition of it as well as the typical representation of combinations and what are the typical words which will be triggering that to find the combination related word, right? So that we are going to look into here in our combinations. And after the combinations, as usual, there will be few properties related to that. So we are going to take a look over the properties of combinations. So if you remember, we have seen properties while dealing with the factorial notation, as well as we have seen properties while dealing with the permutation concept. In the same manner here, even in the combinations, we are going to look over the properties of combinations. And after that, again, the next concept will be combination under restriction. So how we have seen permutation under restriction, in the same manner, there will be some restrictions even for the combination. So that corresponding restrictions and the related combination term, what will be the equation that we are going to, what will be the formula which is required for that particular restriction, that we are going to cover here. And once we are done with the combination under restriction, there will be a one more concept which is division into groups, right? So this will be a new concept which will be involving our both permutations and combinations. So this will be the one. And meanwhile, in between, after the combination introduction, we'll just have a quick difference between a permutation and a combination. So basically, what is the formula difference and what and all the words which trigger permutation and what and all the words which trigger to combination. So these are typical differences or the differences between this permutation and combination. So that also we'll just take a look over that. So these are our concepts in on overall that we are going to cover in our today's session of permutations and combinations. So as I mentioned, we are going to start with finding the rank of a word. So as I mentioned here, I'll be demonstrating you the shortcut method to find the rank of a word, right? So once we learn the shortcut method, then it will be easy to find rank of any given word. right? And with respect to one question, I'll even demonstrate the long method, like the typical expansion method without the shortcut. So that also we'll just do with one simple question, so that you guys can get an idea how we find the rank of a word using a long method, right? So I hope you are clear with it. So we are going to start with finding the rank of the word. So even in this rank of the word, we are having two categories, which means we can say is two types we are having. So the first case here we are having is without alphabet repetition, which means whatever the word we are having, which we are trying to find the rank, there should not be any alphabet repeated. That means there will not be any repetition alphabet in the given particular word which we are trying to find the rank. So that will be the first case while trying to find the rank of the word. Right, so here I have given an example. So I'll just demonstrate the shortcut in order to find the rank of this word mother according to the dictionary. Right. So first, the first and foremost thing here is, so let's write down the word mother here. So this is the word mother here, right? So now the first thing here we have to go to find the rank is, we have to number each of these letters which are mentioned in the word mother according to the alphabetical order, right? So what is the first letter here? E, H, M, O, R, and then T. So in this given word mother, the alphabetical order is E will be the first, and then H will be the second, and then M will be the third, and O will be fourth, and R will be the fifth, and T will be the sixth. So now from here we have to write. So here what is our first letter here? Whenever we are trying to write these numbers, we always look into the right side of the order, right? So the first letter we are having here is mother. So what is the number that we have given for M? That is 3, right? So we have to check from here what are the numbers which are less than 3. So less than 3 we are having 2 and 1, which means there are two numbers which are less than 3. So let's write the 2 here. And now move to the right, move towards right. So here we are having O, which is numbered with 4. So let's check only towards the right. So never look back. You always have to look towards the front, that is your right side. So from here we have to look to the right side and check what are the numbers which are less than 4. Again 2 and 1, which means only two numbers are less than 4 towards the right side. And let's jump to the one step forward, that is right side. For T, what is the number which is given here? 6. So less than 6, how many numbers are there? 2, 1 and 5. So 3. And jump one more step here towards right. And the number given for H is 2. And less than 2 towards right, there is only one number. So here it will be 1. And again for E, jump towards one step right. And then here for E1. So less than 1, there is no number. So you can write it to be 0. Similarly, the next, so there is no alphabet in front of R. So there are no numbers which are less than 5 in the right side of it. So it will be 0 here. Right. So once we have written all these numbers, now once we reach the cornermost right side here, so now we will be starting from here by giving from 0 factorial. So here it will be 0 factorial, and then 1 factorial, and then 2 factorial, next 3 factorial, next 4 factorial, and then 5 factorial here. So how many numbers we are having? So likewise, if there is one more alphabet, 6 factorial. If we have one more alphabet towards left, 7 factorial. So likewise, we will be writing. So once we have done all these factorial and giving these numbers, so now what we have to do? We have to just multiply and add it. So we have to multiply these two terms and we have to add it to this. So it will be here 2 into 5 factorial plus 2 into 4 factorial plus 3 into 3 factorial plus 1 into 2 factorial plus here 0 into 1 factorial will be 0. Similarly, 0 into 1 factorial will be 0. So now we have to calculate this value, that is 5 factorial into 2. So 5 factorial will be 120. 120 into 2 will be 240. And here 4 factorial will be 24. So 24 into 2 will be 48. And 3 factorial will be 6. 6 into 3 will be 18. 2 factorial will be 2. 2 into 1 will be 2. So let's calculate the value here. So 240, 88. And then 318 plus 2. So here 88 and then 20, 98 and 308. So this will be the value 308. But this is not the rank of the word mother. So once we calculated the whole thing, so then the final step we have to add plus 1. That means 308 plus 1 will be equal to 309, which is the rank of the word mother. So the rank of the word mother is nothing but 309. So this is the basic shortcut which we will be applying here in order to find the rank of the word according to the dictionary. Right. So let's have a look once again over our steps involved in the shortcut which we have used here in order to find the rank of the word. So the first and foremost step here is we'll just write down the given word and then one by one we'll just give the letters, numbers according to their alphabetical order. Right, so that's how we have given, and then we'll just start writing the numbers. That means we'll start from the first letter and check what and all the numbers less than that are present in front of it. So likewise we'll be giving the numbers, and then from after when we reach the rightmost side, from there we'll be starting giving the 0 factorial, 1 factorial and so on until the last letter. And at final we have to just product these and then add some the remaining terms which will be giving the answer. At last we have to add 1, that will be our final rank of the word. So this is our methodology to find the rank of the word mother, when rank of the word when the alphabets are not repeated. Right. So which means there will be one more case where alphabets can be repeated. So that we'll be seeing in our further slides. So this is the rank of the word, that is mother. So let's do an example here. So here we'll just try to take a word rank, a word prime. So try and find the rank of this word prime. So first and foremost thing we have to verify here is whether any alphabet which are given in this word are repeating or not. So that is our first thing we have to identify. Once they are not repeating, we can go by the procedure that we have just seen. So take the word prime and try and find the rank of this word. So same procedure you have to follow and let me know the rank of the given word prime. So just recall the steps that we have followed for our previous word, that is mother. So just follow the same steps in order to find the rank of the given word prime. So we can directly identify here there is no repetition of any of the alphabet here within the word prime. So we can go by the first method, that is our first case. So the first step in order to find the rank is to write the alphabetical order. Right, so let's give the numbers of these words, of these letters according to the alphabetical order. So 1, 2, 3, 4, and then R will be the last. So the numbers we have already given according to their alphabetical order. So P will be 4, R will be 5, 1 will be 2, 4 will be 3, and E is 1. So now the next step here is to write the numbers which are less than that towards the right hand side. So we'll start with P. So the number which is given for P is 4. So let's check towards the right of P what are the numbers which are less than 4. 2, 3, 1. So 3 numbers are present towards the right of P which are less than the number given to P. Right. So similar way, jump to R and look towards the, first we have to identify what is the number given to R. So 5, and look towards the right hand side of it and check what are the numbers which are less than 5. So 2, 3, 1. So 3 numbers. And now here, so for I, number is given 2. So less than 2, only 1. And next for M, the number given is 3. So less than 3, only 1 here. And for here, there is no alphabet ahead of it. So obviously it will become 0. Right. So the next step, we'll start from the rightmost side here and start giving the factorials. So it will be 0 factorial, and then move towards the left side. 1 factorial, 2 factorial, 3 factorial, and then 4 factorial. So now the next step will be the calculation, which is product and then sum. So 3 into 4 factorial plus 3 into 3 factorial plus 1 into 2 factorial and then 1 into 1 factorial, and the next one will be 0 into, so it will be automatically, the value will become 0 here. So let's see if anyone has already given the answer. Okay, so you can just calculate the value according to our factorial here. So 4 factorial, it will be 24. 24 into 3 will be 72. And then 6, 3 factorial will be 6. 6 into 3, 18. And then 2 into 1 will be 2. And then 1 into 1 will be 1. So 72 plus 18 plus 3, right? 90. 72 plus 18 plus 3. And then at final we have to add 1. So 72 plus 18 plus 3 will be 93. And then at final we have to add 1. That means 93 plus 1 will be equal to 94. So the rank of the word prime will be equal to 94 here. So this will be the rank of the word prime. Right. So far we have seen finding the rank using the shortcut method. So as I mentioned, there is another method which we can follow the same and we can find the rank of the word. So let's get into that and see the different method apart from the shortcut that we have just learned. So here comes the next question. So the letters of the word ought are written in all possible orders that these words are written out as in a dictionary. Find the rank of the word tough in the dictionary, which means here we have to find the rank of the word tough. So you can give it a try using the shortcut method, and then I'll explain you another method apart from the shortcut. So can you guys take your time and give it a try using a shortcut method and find the rank of the word tough, and then I'll explain you the second method. So quickly find the rank of word tough using the shortcut method. I'll just give you 2 minutes, and then I'll explain you the another method to find the rank of the word. So by looking at the question, some may feel like they have to find the rank of word or, but here we have to find the rank of word touch. So there is a possibility that some might feel get confused here. So now I hope you guys might have solved using your shortcut method. So now let me solve this question using our different method. So here we have to find the rank of the word tough, right? So the first letter we are here having is T. So now let's order these all given 5 letters according to the dictionary, that is according to the alphabetical order. So G, and then H, O, and then T, and then it will be U. Right. So here the first letter of the given word is T. That means all the words which are starting with G, H and O will be coming ahead of tough. So first consider number of words starting with the letter G. That means G, and then 4 gaps. That means in this 4 gaps, the remaining 4 letters can be fixed in 4 ways. That means 4 factorial here. Similarly, number of words starting with H. So that also same thing, 4 factorial. And the next will be O. So for O here, again 4 factorial. And the next will be T. Right. So for T here, because here we have to find the rank of the word which is starting with T. So now we have to go for the second letter. So first letter is already fixed here. So now the second letter can be again according to the dictionary, it will be starting with G. So here the remaining can be arranged in 3 factorial ways. And again here, that means this is TG. Right. So now once TG is finished and the second letter will be H now. So that means TH. That will be 3 factorial here. Once TH is finished, and then we'll be having TO here, which we require TO. Right. So now TO is okay. Now there will be a third letter which will be fixing here, that is G. Right. So here how many factorial which is required? 2 factorial. So now we are with the words TOG is already over, and then TOH. That means again 2 factorial ways. And the next will be TO. The next will be TO. O is already fixed because there will not be repeating here the words. So there is no need to fix O here. The next will be U here. Right. So here TOH is over, and the next will be TOU, and the next will be G, and the next will be H. So this is 1. So the rank of this word is nothing but 4 factorial, that is 24. Here also 4 factorial, 24, 24, and 3 factorial will be 6 here, and then 6 here. 2 factorial will be 2 here, and then 2 factorial will be 2 here, and then here 1. So the rank of this word tough is nothing but 24 into 3 plus 6 into 2, that is 12, plus 2 into 2, 4, plus 1, which is 1272, plus 17, which is equal to 989. So the rank of this word tough according to the dictionary is nothing but equal to 89. Right, so for the reference, you guys can try out using our shortcut method, which we have learned just now. And we have solved questions with respect to that method also. So you can just give it a try and take a look whether using our shortcut method we are getting the rank of the word tough is 89 or not. Right. So you can observe that using this method it's actually a bit lengthy when compared to our shortcut method. So we prefer, as we are doing objective questions, it is preferable to you guys to follow the shortcut method in order to find the rank of the given word in the dictionary. Right. So now so far we are dealing with the case 1 in finding the rank of the word, which is where the alphabets are not repeating. So there is one more case where the alphabets will be repeating. So let's jump into the case 2 and see the procedure in order to find the rank of the word. So here comes the next case where the alphabets which are given in the word will be repeated. Right. So for example, you can see a word here which is secret. So here we are having a word secret. So if you observe in this entire word secret, E is actually repeating twice. So if we compare with our previous case, there are no alphabets repeating there. Whereas here, there are alphabets present here which are repeating. Right. So now the procedure will be somewhat different, but the starting steps and all will be as usual as how we have done for the previous case. So first and foremost thing here, we have to give the alphabetical order here. So 1, E will be 2. So as we have 2 E's here, it will be given 2 times E. Sorry, given number 2 twice. Right. And then R will be 3. S will be 4. And then T will be 5. Right. So now what we can do, same thing, we'll start from S and we'll check the number given to S, that is 4 here. So let's check the numbers which are less than 4. So 1, 2, 3, 4. So as 2 is repeated, we have to count that twice. Right. That means 1, 2, 3, 4. So this is 4. And as they are repeating, so from here, we have to check how many times the alphabets are repeating. Only E is repeating, that too twice. So it will be divided by 2 factorial. Right. So 4 divided by 2 factorial. So this is the only change we can observe here. So whatever the alphabets repeating and how many times is repeating, so that have to be divided. So like how we have seen while dealing with like objects. So if we are having a same kind of like objects, we are going to divide that. So the same procedure will be applicable here. So now let's jump into the next letter, that is E, and check what are less than E. So only 1. So here it will be 1. And from here, so from E we have to identify how many alphabets are there and how many times they are repeating. So only E is repeating here, that is twice. So divided by 2 factorial. And from C here, less than 1, not present, so 0. And from C, is there any alphabet repeating? So CR it is, there is no repetition here. So we can leave it like that. And for R, less than 3, it will be 1. And from R, you can see any alphabet is repeating? No, right? So 1 will be the same here. And less than 2, 0. Less than 5, 5. And there are no repetitions here. So the next will be the same step. 0 factorial, 1 factorial, 2 factorial, 3 factorial, and then 4 factorial, and 5 factorial. So the only difference we'll be identifying here is the division of the number of times the letter is repeating. So now the next step will be the same, multiplication and adding. So 4 by 2 factorial into 5 factorial plus 1 by 2 factorial into 4 factorial plus, so 0 into 3 factorial will be anyways 0, plus 1 into 2 factorial will be 2 factorial, and then 0 into 1 factorial will become 0, and here also 0 into 0 factorial will become 0. So now we have to only calculate these values. So let's find out the value. 4 by 2 factorial is nothing but 5 into 4 into 3 into 2 factorial. That is 5 into 4, 20, 12. So 20 into 12, 240. So this value is 240 plus 1 by 2 factorial. So 4 into 3, it will become 12. And then 0 and then 2 and then 0 and then 0. So it will be 14. So 254. So after the calculation it is 254. But at last we have to add 1. So 254 plus 1 is equal to 255. So the rank of the word secret is nothing but 255. So now you can identify the difference between the procedure when we have alphabets not repeated and when we have alphabets with repetition. Right, so this division will be the major difference here, and the remaining steps in the procedure will be the same thing. And here the rank of the word secret is 255. So now let's give you, I'll just give you a few questions related to this in order to practice. So let's just have move on to the next question. So find the rank of the word Google in the dictionary. So now you can identify in the Google there are repetitions of the alphabet. So try and find the rank of this word Google. So quickly do it. So here you can identify this word Google will be falling into our second case which we have discussed just now. So follow the procedure and let me know the rank of the word Google. So if anyone got the answer, you can let me know. Rank of the word. So here we are having two letters with repetition. So G is also repeating as well as O is also repeating here. Which two alphabets are repeating. So first and foremost thing we have to follow here is numbering the alphabets in the according to the alphabet order. Right. E and then G, L and then O. So let's start with the first letter G and see less than 2. How many are there? Only 1. And from here, including G, how many letters are repeating? So G is repeating how many times? 2 times. So divided by 2 factorial. As well as O is repeating, that is 2 times. So divided by again 2 factorial. And now jump one step ahead. So now O less than 4 will be 2, 3, 1. That will be 3 divided by. So now we have to check including O to the right side how many alphabets are repeating. So O is repeating twice. So it will be 2 factorial. And here from here there is no G repeating because we left the G behind. So only 2 factorial. So now the next one will be O. So less than 4 again it will be 3. So now there will be no repetition of letter from this O to the right hand side. So there will be no division of 2 factorial here. And for the next letter it is 2. So less than 2 only 1 here. And then for 3 less than 3 it will be 1 and less than 1 here it will be 0. So the next step will be from the rightmost side we'll just start giving 0 to plus 1 factorials to the left side. That means 0 factorial here, 1 factorial here, 2 factorial, 3 factorial, 4 factorial and 5 factorial will be here. And what about the next step guys here? We just have to multiply these two terms and we have to add it. So let's do that. That means 1 by 2 factorial into 2 factorial into 5 factorial plus 3 by 2 factorial into 4 factorial and then 3 into 3 factorial plus 1 into 2 factorial plus 1 into 1 factorial and the next one 0 into, so this will become 0. So let's simplify this in order to get the value. So 1 by 2 factorial will be 2 and then this will also be 2. Here 5 into 4 into 3 into 2. So this 2 will get cancelled. 5 6 are 30 here. So this will be the value 30 equal to 30 here. So the next one will be 3 divided by 2 factorial into 4 into 3 into 2 factorial. So this will get cancelled. So 4 3 is 12, 12 3 is 36 here. So this value will be equal to 36. And then 3 factorial will be 6. 6 into 3 will be 18. So 30 plus 36 plus 18 plus 2 factorial into 1 will be 2 plus 1 plus 0. Right. So let's just calculate the sum of these values, that is 30 plus 36 plus 18 plus 2 plus 1 which is equal to 87. But this will not be the exact rank of the word. So now we have to do plus 1. So 87 plus 1 will be equal to 88 which is the rank of the word Google in the dictionary. So now the required rank of the word Google is equal to 87. Right. So this will be the rank of the word Google. So this is how we'll be finding the rank of the word if the letters are repeated. So let's just see one more example related to this case where the letters are repeating and then we'll just jump into our next concept. So now try to find the rank of the word India. So quickly try and find the rank of the word India, guys. So here in this word India, there are one letter which is repeating, that is I. So the procedure as well as the steps will be the same as how we have done to the previous one. So this will be a easiest one as the letters are less comparatively to our previous words. So you can do it simply, easily, and let me know the rank of this word India. So I hope some of you might have solved it. So please let me know the answer, guys. What is the rank of the word India here? So what is the numbering we should be given? So A will be 1, D, I. So I, as I letter is repeating, so number 3 will be repeating, and 4 here. So let's start with here. So less than 3 will be 2 and 1. So only 2 divided by which are repeating, that is 2 factorial. And here less than 4, 1, 2, 3. So here 3 divided by any letter is repeating. No, right? So we can leave it like that. So let it be 1 factorial because it's the same thing. So from here less than 2, only 1. No letter is repeating. So less than 3, only 1, and no letter is repeating, and less than 1, 0. So from here we'll start giving 0 factorial. So 0 factorial, 1 factorial, and then 2 factorial, 3 factorial, and 4 factorial. So now just do the product and add it. So 2 by 2 factorial will be anyways 1. So it will be 1 into 4 factorial plus 3 into 3 factorial plus 1 into 2 factorial here, and then plus 1 into 1 factorial here, and the last one 0 into, so anyways the value will become 0 here. So what is the 4 factorial value? So 24, and then 3 factorial will be 6. So 6 into 3, 18, and then 2 factorial, it will be 2 into 1, so it will be 2. So 1 into 1 will be 1, and then 0. So now 24 plus 18 will be 42. So 42 plus 3 will be 45. And now this is our final calculation. So to the final calculation, we have to add plus 1 in order to get the rank of the word. So now 45 plus 1 will be equal to 46. So this will be the rank of the word India. So let me see if anyone has already given the answer. So I hope you guys have given the answer. Okay. So now the rank is nothing but equal to 46. So the rank of the word India according to the dictionary is 46. So that's all for our rank, guys. So now so far we have seen our rank in the 2 specific cases, as we have seen our 2 methods of solving. So majorly we have solved using shortcut method, but I have already explained you the another method, which is the long procedure method. That also we have done, and we have solved question related to that also. So these are the type of questions you can expect with respect to the rank questions and all. So with this rank, we almost finished our concept of permutation. So now we are going to enter into the combinations. So first let's see the quick definition of what is this combination, right? So each of the different groups or selection which can be made by some or all of a number of given objects without reference to the order of the objects. So as I mentioned while we are discussing the permutations in detail, I have mentioned that the order of the objects is very important, and that is reference, right? Whereas here by some are taken without reference to the order, so here order is not important, right? So without order whatever we are selecting the people, so that will be categorized as a combination, right? So now let's see the formula related to this combination. So the number of all combinations when n objects taken are at a time. So initially if we have n objects and taken r at a time, the number of permutations will be npr. So whereas if we have n objects and taken r at a time, the number of combinations will be given by ncr, and the expansion of ncr will be equal to n factorial by r factorial into n minus r factorial. So there is a new term added here with respect to the permutations, that is r factorial, right? So this is the expansion of ncr, that is the combination. When we have n objects and taken r at a time, the general number of combinations is given by ncr, which is equal to n factorial by r factorial into n minus r factorial, right? So now let's see few properties which are related to the combinations here. So first one, NCR will be equal to NC and minus R. So for suppose if we are having NCR, that means 5C2. So this 5C2 will be equal to 5C, 5 minus 2 will be 3. So 5C2 as well as 5C3 both will be equal according to the first property here, right? So similarly the second property states here NCR plus NCR minus 1 will be equal to N plus 1 CR, right? That means if you are having 5C2 and then 5C1, so these two sum will be equal to 6C2, right? So you can check by expanding it if you want for the reference, right? So this will be the second step. So basically these all properties will be applicable or useful when we are dealing questions, so that at that time you will be understanding the importance of these properties of combinations as well as the permutations also, right? And the next property states that if we are having ncx which is equal to ncy, and then we can establish a relation between this nx as well as y. So that is nothing but here both x and y will be equal, and or it can be, so either it can be x equal to y, one possibility, or it can be the value of x plus y can also be equal to n. So whenever you can see this type of expression where ncx is equal to ncy, so you can conclude either of these two. The one will be x equal to y and the other will be x plus y is equal to n. So we can be concluded with either of these two conclusions based upon the situation. And for this typical expression, that is ncx is equal to ncy, right? And let's see the next property here. If n is even, the greatest value of ncr is ncn by 2. If the n value is even and the greatest value of this ncr is given by ncn by 2. Similarly, if n is odd, the greatest value of ncr is given by ncn plus 1 by 2. So this greatest and smallest value, again you will be coming across this greatest and smallest, greatest and greatest value when n is even and n is odd, when we are dealing with our chapter binomial theorem. So in our binomial theorem, we will be having everything related to this combination C0 and all. So there we will be again getting this greatest value of related to the related to the combinations here. So these are our 5 properties related to the combinations. So let's move ahead, guys. So we have seen the basic definition of our combination, and then we have seen the typical representation of it, the formula related to that, as well as the properties related to the combinations. So we have covered all these concepts related to combination. So now as we have finished some of the part related to the combinations, so now let's just have a comparison of permutation as well as the combination. Right. So basically what is the difference we can identify in between the permutation and the combination here. Right. So first let's start with the permutation here. What actually this permutation states? So different orderings or arrangement of the R objects are different permutations, which means here order is very important, and the permutations is given by NPR, which is equal to n factorial by n minus R factorial. Whereas for combination, it will be a choice, right? It will be a choice or a subset of R object given one combination order within the group of R objects, which means for suppose we are having AB and BA. So in permutations, these will be regarded as two objects. So AB is one object and BA as one object. Whereas in combinations, AB and BA, so both are regarded as one, because order here doesn't matter, whereas in permutations order does matter. Right. So now we can have some clue words which actually states that here we have to do this permutation and here we have to go by this combinations. So let's have a look over the clue words which trigger us to get the permutations or the combinations. Right. So here the clue words which are related to the permutations is nothing but arrangement, schedule, order. So whenever you can see words like arrangement, schedule and order, so these clue words trigger here that to permutations. And in the similar way, there are few clue words which trigger the combinations, which are nothing but group, committee, sample, selection, subset. So these are the few clue words which will be triggering us to the combinations. So the basic difference here order is different. Order does matter. Here order doesn't matter. And NPR expansion will be equal to n factorial by n minus R factorial, and NCR will be expansion of it will be n factorial by n minus R factorial into R factorial. Right. So now can we establish a relation between these two here or not? Yes, we can establish a relation between here. That is nothing but NPR will be equal to R factorial into NCR. Right, because if we multiply with R factorial, so this R factorial and the denominator R factorial will be getting cancelled, which will be equal to this. So the relation between our combinations and permutations is nothing but equal to NPR equal to R factorial into NCR. So this is the relation between permutation and the combinations here. Right. So let's see a question here related to the combination. So just now we have seen combination definition and the expansion of it. So let's do a question related to the combination here, and then we can just wind off our today's session. So pay attention to the question, read out the given information carefully and try and answer the question. So read the question. As it's a word problem, we have to understand the question carefully in order to answer it. So that's the trick here. So we have to be very, very careful while reading the question and writing down the given information. So take your time, guys, and read it carefully. If you have any doubts, any trouble, if you are facing anything, you can let me know in the comment section. So let's read the question here. A basketball coach must select 2 attackers and 2 defenders from amongst the 3 attackers and 5 defenders. So how many different combination of attackers and defenders can he select? Right. So here, to form a basketball team, a coach must select 2 attackers and 2 defenders. Right. So we are required here attackers and defenders. So how many total number of attackers here? That means n. So 3 attackers in total. And how many defenders? That is n here, 5. Right. Amongst these 3 attackers, the coach must select 2 attackers. That means R will be 2. And amongst these 5 defenders, the coach must select 2 defenders. That means R will be equal to 2. So in a basketball match, both the attackers as well as defenders will be present. So if we consider this as attackers as our experiment 1 and defenders as our experiment 2, so both the experiment must be formed simultaneously, must be performed simultaneously. Right. So here, amongst these 3 attackers, he has to select 2 attackers. That means the number of combination for attackers will be, that means for we can take it as for attackers. The number of combination for attackers, it will be 3C2. Because amongst 3 attackers, the coach must select 2 attackers. So in the same way, what happens for the defenders? Amongst 5 defenders, the coach must select 2 defenders. So it will be 5C2. So now, the coach has selected attackers, that will be 3C2, and for defenders 5C2. But now here they are asking how many different combination of attackers and defenders. So both has to be combined, which means both the experiments must have performed simultaneously. So whenever we have experiments performed simultaneously, which fundamental law it will be? It will be the multiplication law. That means here it will be 3C2 into 5C2. So now we have to expand it and find the answer. 3 factorial by 2 factorial into 3 minus 2 factorial. Cross here 5 factorial by 2 factorial into 5 minus 2 factorial. Which means, so let me write down here 3 factorial by 2 factorial. So 3 minus 2 will be 1 anyways. And then here 5 factorial by 2 factorial and 5 minus 2 will be 3 factorial here. So 3 by 2 will be 3 only, 2 factorial will get cancelled, and 5 into 4 and 3 factorial will be getting cancelled. Here we are having 2, so it will get cancelled 2 times. So 5 into 2, 10, and 10 into 3 will be 30. So the coach will be selecting in 30 different combinations of attackers and defenders in order to form a team here. Right. So this is the, we'll be applying our combination concept when we have to select or pick people. Right. So this is the basic introduction to our combinations, and we have even seen the properties related to the combinations. Right. So that's all for today, guys. So we can just wind up our session here. So in our next session, we'll just continue with our combinations. So far we have finished our introduction part, and then we have finished our permutations, and we have finished our finding the rank of a word and all. So these are the concepts which we have finished so far, and just now we have entered into the combinations concept. So now we'll just continue the rest with respect to the combinations, and we'll just continue the combinations topic in our next session of permutations and combinations. So that's all for today's session, guys. So if you have any doubts, any questions, you can kindly let me know in the comment section. That's all for today.